So today we're going to be talking about analyzing graphs of polynomial functions. Right here you'll see a screenshot from a program called Desmos. It's a program you guys are going to get pretty familiar with. I've linked the website and the tutorial to using this program right on Google Classroom. You guys should have access to this app in self-service on your iPads as well. But we'll be using this program to graph our functions and get some specific information from it. So the graphs you're going to see in the next couple slides are going to be from this program. I took screenshots of them and put them into my presentation here. So the graphs you guys have are blank. So I want you to, when you have a problem, you're going to sketch the graph out. So I was just trying to make it nice and clean for you guys to see. But again, there's a tutorial right on Google Classroom. It's pretty easy to use, the program itself, so you shouldn't have too hard of a time, but there is that information there as well. All right, so these are the things we're going to be looking for. So we're going to first state the maximum number of turns that the graph could have. Now, this is always going to be the maximum number of turns it has is always one less than the degree of the function. Now, remember, the degree is the biggest exponent. You're going to also have a sketch of the graph. You're going to state the number of real zeros. So remember, that's where our graph crosses the x-axis. And then we're going to estimate the value of those x's, so the zeros of the function. And then we're going to talk about relative max and min. So these are where like the turning points are on our graph. We're going to get the coordinates for those. And then we're going to talk about the end behavior. So as our graph is moving on the left side, is it moving pointing up to positive infinity or down to negative infinity? And on the right side of our graph, as we're moving where x's are headed towards positive infinity, are we pointing up towards positive infinity or down towards negative infinity? So these are going to be the 6 key points that we're going to touch on for each of these graphs. All right, so for this first problem, we're given the function f of x equals negative x to the third minus 4x to the second plus 5. So I graphed that on Desmos, and I got the visual for this as well as a bunch of coordinates that are going to be useful for the information we're looking for. So what I would do if I were sketching this graph out myself is I would probably gather all this information first, and then I would go through and sketch the graph. So for this first part, we're stating the maximum number of turns that the graph could have. Now we want to look at the degree, so the biggest exponent, and we want to subtract 1 from that. So the maximum number of turns that this could have is 2. Now that doesn't mean it has to have 2, but it could have up to 2 turns. So we have a sketch of the graph already. Next is state the number of real zeros. So remember, that's where we cross the x-axis. And we cross the x-axis only once. So we have 1 real zero, and then we're going to approximate that. Now on Desmos, if I click on that 0, it actually gives me the coordinate. So this right here is the coordinate for that 0 of the function where we cross the x-axis. So it says to the nearest tenth, so I'm going to round that up to 0.90. All right, and then we're going to approximate the relative min and max. So that just means in certain parts of our graphs, what's the highest point, what's the lowest point. So we're going to look, and it's really going to be our turning points here that we're talking about. So we have a min here because it's a lower point, and we have a max here because it's a higher point. So if you think about back to when we were graphing parabolas, we also used the words maximum and minimum, and that referred to those values for the vertex. So it's the same kind of idea here. All right, so we have a max at 0.5, and we have a minimum at this point right here, so it says round to the nearest tenth, so I'm going to say negative 0.9 and 3.9. All right, so again, these are basically the turning points here. If it's a lower, like at a dip, it would be a relative minimum. And if it's at the top, it's a peak of something, it's a relative maximum. Now we don't have like anything down here being a relative max or relative min, because even though it's a lower part of our graph, we don't have any turning points there. So that's really kind of a key. All right, and then lastly, we're describing the end behavior. So as x heads towards negative infinity, so the left side of our graph, we are headed up towards positive infinity. All right, and as x heads towards positive infinity, so that's this side of the graph, headed to the right, our graph is pointing down towards negative infinity. Now with this next graph, we do have a little bit more going on. So you'll see quite a few more coordinates on my graph here. So I'll try to help us make sense of this all as we work through it, because there's a lot of things on top of each other. But first off, we want to state the maximum number of turns. So again, that's 1 less than the degree. So that would be 3 in this case. And we do have 3 turns, 1, 2, 3. Sketch the graph. So again, I'd go through, get all your information first, plot your points on there, and then do a sketch of the graph. All right, so we have 4 real zeros here. We have 4 places where we cross the x-axis. All right, and those are at, let's see, we have negative, so we're rounding to the nearest tenth, so I'm going to shorten these up a little. So negative 1.40, negative 0.60. Let's see, we have 0.50 and 2.50. So again, I'm rounding all of these, so they're going to look a little different than what you see exactly on the graph. But I rounded these all to the nearest tenth. So those are our zeros of the function. So I'm just going to cross those out because we've already used them. That way we can focus in on the other information. So the next thing we're going to look at is the relative max and relative min. So again, those turning points. So we will have 2 relative minimums here. I'm going to write those both in. All right, and you can have more than one. So our relative minimums are at, again, rounded to the nearest tenth, negative 1.1, negative 1.0, and so that's here, which is this point, and this point, which is at 1.8, negative 7.3. All right, and then we also have a maximum here at 0, 1. All right, and then lastly, we're going to describe the end behavior. So remember a couple lessons ago, we talked about even and odd degree functions. So since this is an even degree function, we have to the 4th degree. That means we're going to have our graph, our ends of our graph pointing in the same direction. So remember that an odd degree function has the ends pointing in opposite directions. So here, as we move to the left, towards our x's being more negative, we're pointing up towards positive infinity. And as we move to the right, where our x's get more positive, we're moving up towards positive infinity. So our end behavior is positive infinity for both sides of our function. All right, so after I would get all that information, I would make a sketch myself if I didn't have this screenshot here. But that's what we're doing for each of these problems. So I'm going to do one more. I would, if I were you for this last problem, I would maybe pause the video, try to do this on your own using Desmos, and then play the video to make sure you got it right. All right, so again, I'm going to look at my function to see the maximum number of turns. Since this is a cubic function to the third degree, I'm going to subtract 1, and I could have at most 2 turns in my function, which I do have here. I have one real 0, and that real 0, rounded to the nearest tenth, is at negative 1.10. My relative max is at 0.5. My relative min is at 2.1. All right, and then the left side of my graph, so as my x's get more negative, I'm pointing down, so it'd be towards negative infinity. And as we move to the right, that end of my function is moving towards more, our x is being more positive. That's pointing up towards positive infinity.